Today we'll start the permutation and combination part. Basically, there is a thing, Combinatorics. It is a branch of mathematics that deals with the counting rules that includes permutation and combination. Basically, this is a branch of mathematics that deals with the counting principles, which are the permutation, combination, and which are prerequisite for the probability part. So before getting in detail about the permutation and combination, what is the difference between them? How can we identify whether that is a permutation question or combination question? We need to understand few things. The first one is that how can we identify whether we need to add or we need to multiply two events? Two events are more than two events, right? So first thing is, how can we identify whether we need to multiply or add those events? So yes, or and those are the keywords, but it doesn't matter that you always be provided with the or and. Okay, so first of all, let's see the scenario in which we add up. Okay, so to get an idea about this, first see a scenario. A person who wants to goes out of his house and he has two types of shoes. Two types of shoes and 4 types of sandals to wear. And he could wear either shoe or a sandal. So the question is, in how many ways he can decide what to wear? Question is ways, how many ways to decide what to wear? So if you see this scenario, there's a person who wants to go outside and he wants to choose the dress and shoes, and he has 2 options for shoes and 4 options for sandals. And he could wear either shoe or a sandal, not both of them at the same time. The question is how many ways he can decide what to wear. So if you see in this scenario, you are provided with 2 things. One is the shoes, and other one is sandal. And he has 2 shoes and 4 sandals. And for example, shoe, you have one is S1, other is S2, and this is X1, X2, X3, and X4. So if I want to write all of the events, what could be the first one? He can wear S1 shoe, or he can wear S2 shoe, or he can wear X1 sandal, or he can wear X2 sandal, or he can wear X3 sandal, and the last one is he can wear X4 sandal. There is one neat thing to understood in this. What or exactly mean in this scenario? The R emphasizes the fact that he cannot choose both of the different shoes or shoe and sandal at the same time. He need to choose one, either S1, either S2, either X1, X2, X3, or X4. So in total, the person has 6 ways to choose either sandal or a shoe. And if I write this, how can I write this? I can write this as he will wear a shoe, or he will wear sandal. And for the shoe, he has 2 options, S1 or S2, and or X1 or X2 or X3 or X4. So in first scenario, he has 2 options, and last scenario, he has 4 options. And overall, remember one thing, whenever you see the keyword or mean, you need to just add those events up. That will be 2 plus 4 is equal to 6. So there are in actual 6 ways to choose whether he want to wear shoe or a sandal, right? So this is a keyword to identify that you need to add those events up. This is first way to identify. When you see you will add when you see or between the events. And other thing is, if you have more 2 events or more than 2 events, and there is a condition that both of for example, you are considering 2 events, and those 2 events can't occur simultaneously. In that scenario, you need to add those events out, right? You can also write this as in which the occurrence of one does not affect the occurrence of other. Or you can also say that in which the events are mutually exclusive. We will see this term when we'll move to the probability part, mutually exclusive. Right, so identify when to add. There are 2 scenarios. Either you will identify the keyword or you will see that whenever you have 2 or more events and the occurrence of one does not affect the occurrence of other, in that scenario, you just need to add those event out, right? So everything is understood till now? This was first scenario about the OR case. Now,
Yes.
And there is one more thing. Based on this scenario, there is a rule of sum. And the rule of sum says that if there are A ways of doing one thing and B ways of doing another thing, then the number of ways doing either of 2, just see the keyword, either of 2, but not both, is just equal to A plus B, right? When you have 2 events, one event there are A ways of doing that thing, another there are B ways, and when we're asked to find that the number of ways doing either of 2 events, and remember both of these can't happen at the same time, in that scenario, you will just add those events out. This is first scenario. Now let's see the other one, and we see when we will multiply. Okay. The keyword which is used to identify this is and. And just as a scenario we met earlier, suppose again a person wants to go outside, and now the person has two different type of shirts and 4 different type of trousers. So he will wear both shirt and trouser at the same time, definitely. In how many ways? He can decide what to wear. Right? This is similar to the old scenario. In this scenario, we are provided with 2 different type of shirts and 4 different type of trousers. The question is, he will choose shirt and a trouser at the same time. The question is, how many ways he can decide what to wear? And if we see that if this is shirt and this is trouser, and let's suppose this is S1 one shirt, second shirt, this is first trouser, second trouser, third trouser, and fourth trouser. And if I want to no, this is not permutation. We will discuss the permutation and combination in detail a bit further. This is a sort of basic for that. Okay, so the first thing is the person can wear S1 shirt and T1 trouser, the first thing. The second is he can wear S1 trouser, S1 shirt and T2 trouser. Third one is S1 and T3, and fourth one is S1 and T4, S1 and T3, and S1 and T4. This is second, this is third, and this is fourth. The other one is he choose S2 shirt and T1 trouser, S2 shirt and T2 trouser, S2 shirt and T3 trouser, and S2 shirt and T4 trouser. These are first 4 ways, and the other next ones are S2 and T1, S2 and T2, S3 and T2, and S4 and T2, right? T4. So there are 4 outcomes and 4 outcomes. In short, there are total 8 outcomes. So if I want to write this as, how can I write this? Total outcomes will be equal to, he will wear a shirt and he will wear a trouser. So in shirt, he has 2 options, S1 or S2. And in trouser, he has 4 options, T1 or T2 or T3 or T4, right? So 2 for this and 4 for this. And whenever you see and, just multiply that change into multiply sign, this will become 4, and total 8 ways. So this was about the when we will multiply the cases, multiply the events, and takeaways. Whenever you see, you will multiply whenever you see the keyword and whenever you have 2 or more events, and the occurrence of one event affect the occurrence of other, or you can say that both events can occur simultaneously. In that scenario, just multiply the events out. Right? So this was a bit idea about when we will multiply and when we will add. And based on this, there is a rule of counting which states that if there are A ways of doing something, of doing one thing, and B ways of doing another thing, then there are total A into B ways of doing both things. Right? So first there were rule of sum, and now the rule of counting. So this was a bit idea about when we will multiply and when we will add. So we will solve various questions in the next class, and you will see that how such question could be asked, which incorporate this addition and multiplication concept. But till now, is everything understood by all?
Yes.
I try to keep this very simple so that everyone can understand. Okay, so before getting further, there are 3-4 terms which needs to be understood, because that could be asked. The first thing is about the sample space. These are, you can say, common terms which everyone should know. The first thing is sample space. Sample space is actually a set from which all selections are made. Right? So this is the original set from which all of the selections, whatever you choose out of this set, which is called a sample space. There are other names as well, but in probability and combination, usually that is called as a sample space. The next thing is sample size. Which is actually the total number of elements in sample space. Whenever you see sample size, that's mean how many elements are there in a sample space in the original set. The next one is about the sampling. And sampling is actually a process of selecting elements from the sample space. This is actually a process of selecting elements from the sample space. And the fourth one is repeated sampling. You will see this thing again and again. What is repeated sampling? If the selection is made more than one time from the sample space, if you are choosing more than one time, let's suppose you are picking one ball and then again you are picking another ball. So you are just having selection more than one time. If selection is more than one time from the sample space. And the last one is the number of outcomes, which I believe all of you know, the total number of ways selection can be made, number of outcomes. Okay, there is one thing, if you see this repeated sampling, that's mean you are selecting more than once. In this scenario, there are two things which needs to be understood. One is about the order, and one is about whether this is without replacement. So there are basically two main components in this. One is order and one is replacement. By replacement, I mean there could be two scenarios. If this is with replacement or without replacement. And whether the order matters or order doesn't matter. Right? So in repeated sampling, when you are choosing item more than once, in that you need to see whether the order matters or order doesn't matter, or you are picking with replacement or without replacement. And these are very important things which you need to understand. And once we proceed further, we will see that how can we identify the difference. Okay, shall I move forward? Okay, now the very important part is about the permutation and combination. Oh, this is not probability. Probability will be discussed in next two classes, hopefully. Okay, so now the very important thing is about the permutation and combination. Okay, so to get an idea about the difference between permutation and combination, we will see two scenarios. And in first scenario, for example, we are given that this is scenario 1 and this is scenario number 2. In first scenario, we are given that from 3 players X, Y, and Z, how many double teams can be formed? That from 3 players X, Y, and Z, they are 3 players. How many double teams could be formed? Can be formed. The other one is from 3 digits X, Y, and Z. How many two-digit words? How many two-digit words can be formed? So there are two scenarios. In first scenario, we are provided that we have 3 players X, Y, and Z, and we want to form double teams out of those. How such teams could be formed? And the second one is we have 3 digits X, Y, and Z. Question is how many two-digit words can be formed? Anyone can tell whether scenario 1 is about permutation or combination, and what about scenario 2? Anyone?
A is combination, scenario 2 is permutation.
Okay, exactly. First of all, you are making a double team, right? So let's see each of these in detail. First of all, consider scenario 1. And let's move forward based on scenario 1. Okay. So let's see if we see the scenario 1. And in scenario 1, we have 3 options X, Y, and Z. And first of all, tell me how many total outcomes can we make based on these. For example, this could be team XY, team XZ, then team YX, then team YZ, and in last team ZX and team ZY. Now tell me one thing, if you're making a team and you're selecting 2% for the team, will order matter whether you are choosing the first one or second one? No. Unless I specify that I'm choosing the first person for the, let's suppose if I for the bowling and second for the batsman, or first for a batsman, second for a bowling, in that scenario order will matter. But right now I'm just choosing a team out of 2, and doesn't matter whether I'm choosing first X or first Y, or first Y or first Z. In short, I'm just choosing a group of 2. And unless I specify that the first person is doing this task and second person is doing that task, in that scenario, you can say that the order will matter. Right now, whether that is XY or YX, it doesn't matter. Getting the point? We are just making the team, right? The team means a group of 2. And it doesn't matter whether a group of 2 include X at first or Y at first, or Y as first or X as first. It doesn't matter, because this is just a group of 2. Unless I specify that the first person will do specific task and the second person will do specific task. In that scenario, the condition will be different. The order will matter. Got the point?
So here we don't divide the total outcomes by 2 because of the repetition, like XY is equal to YX.
Yeah, because in this scenario, XY is equal to YX. So in short,
Okay.
how many total outcomes will be in this scenario? In this scenario, first of all, this is, if this is 1, this must be equal to this thing. And XY, if this is 2, this must be equal to this thing. XZ, this thing, and this will be equal to this. So in short, there will be only 3 options, which is XY, XZ, and ZY, or Z, X, Y, Z. There are only 3 options available.
Yep.
Okay, so now, and there are certain keywords which we can use to, and this is a combination problem. And remember, in combination, order doesn't matter. Whether the person X come first or Y come first, it doesn't matter, right? So there are certain keywords which can be used to identify. In general, you may get to see identify these keywords. 4 keywords: select, choose, pick, or combination. Whenever you see usually these 4 keywords, that means the question is about the combination. But this is not the hard and fast rule. I will explain later why I'm saying that. But in general, these 4 keywords are used to identify the combination problem. If you see these 4 keywords in a question, that's mean that question is the combination question. But you need to be cautious, because in the same question, the person at first, the question at first shows that the question is about the combination, but later he used a keyword for the permutation, so the question become permutation. So you need to be cautious while solving this if you want to identify the keywords. Okay, I will talk about this a bit later again, a bit about this later again. So what exactly is combination? Combination is a way of selecting items from a collection or the sample space. You can call this collection or the sample space, such that the order does not matter. Right? And there's one more thing. This could be with replacement or without replacement. We will see 4 scenario in the last that incorporate the permutation and combination along with the order and the with and without replacement case. And so the formula for the combination is NCR. And what is it, the NCR? This means that we are selecting R items from a total of N items. Selection of R items from a total of N items. And this formula is equal to N factorial divided by N minus R factorial into R factorial. And exactly what is factorial? If this is N factorial, this means you will keep multiplying 1 less N into N minus 1 into N minus 2 until the 1, right? Okay, so this formula is NCR. That's mean we are selecting R items out of total N items. That will be N factorial divided by N minus R factorial into R factorial. If you see the old question, we have total if you see the first scenario, which we are discussing, we have total 3 options, X, Y, and Z, and we want to make a team of 2. So here N is equal to 3, R is equal to 2. So using the formula NCR is equal to 3C2, that will be 3 factorial over 3 minus 2 factorial into 2 factorial, that will be 3 divided by 1 factorial into 2 factorial. And we can write 1 factorial as 3 into 2 factorial divided by 2 factorial. So in total, there are 3 ways. Right? So even got the idea, basic idea about the combination. Right now, we are identifying through keywords. I will explain another way to identify, but that is a permutation or combination problem. Yes, I'm already recording. The next thing is about the permutation, and for that we need to see the second scenario. I will get back to your question after this. And in that scenario, we have 3 letters X, Y, and Z, and we want to form a 2-digit word, a 2-digit letter, or and how many such words or digits are possible? 12. Okay. And if I just make the possible outcome, that is XY, XZ, YX, and YZ, and ZX, and ZY. So right now there are 6 ways. But remember, XY in this scenario is not equal to YX. Everyone got the point of why in this scenario XY is not equal to YX? If we consider this as a digit, 3 to 2 is not equal to 3. Or if I consider this as a word, AB, X, consider AB is not equal to BA, because both if are having a different meaning and these two are not equal. So in this scenario, when we are making a word, we are making a digits, and when you are making a number, the order will matter, and that will be a permutation problem. And the formula for the permutation will be NPR will be equal to n factorial divided by n minus r factorial. And this means we are arranging our items from a total of n items. And if you want to, for example, if you want to define, there are basically 3 main keywords to identify that this is a permutation problem. That is arrangement, ordered way, and the third one is unique. I told you earlier that in GRE, this is not a good data to identify through keywords, because just consider a case in which a question first asks to select, but in the last it asks the ordered pair, the unique pair. So in that scenario, you need, if you want to consider the unique, that will be permutation problem. So there must be some other way that we need to identify whether there is a permutation problem and combination problem. Let's see that. But before getting into that, we can write this NPR, which is equal to n factorial over n minus r factorial, and NCR is equal to n factorial over n minus r factorial into r factorial. By formula, what is the difference between these two? The only difference in denominator, there is no r factorial in NPR. That's mean we can write NPR as NPR is equal to NCR into r factorial. That's mean this thing is permutation of r items out of n items. This is selection of r items out of n items. And this is arrangement of those r items. R items are arrangement of all selected items. So if we incorporate the selection in the NCR formula, that will exactly be equal to the permutation formula. Okay, so now let's see another way to identify whether the problem is the permutation or combination. Permutation or combination. First is through the keyword, and just like the two scenario we discussed earlier, just see one thing, that is the reason same if the reason of selection is same or different. Selection is same or different. What exactly this mean? That, for example, if I consider a case, I want to selecting two colors for a license plate, two colors, and first color is for the background and second color is for the alphabets. For example, I choose first blue for the background and green for the alphabets. And can I say that this BG will be equal to GB? No, because if I do that, that's mean that now I am selecting G for the background color and the blue for the alphabets color. And now if you see, the reason of selecting both of these are different. The first one is selected for the reason of background and the second one is selected for the reason of the alphabets. So whenever you see this way that the reason of selection is not same, in that scenario, the order will matter. So in short, when reason of selection is not same, order will matter. I even got the point, and that will be a permutation problem. Getting the point? Please let me know if anyone is confused. This is first thing, that if I want to identify the order, think that is the reason of selection is same. For example, you are having two repeated sampling of two, in which first you are considering a license plate case, and first you are choosing two colors. First color is for the background and second color is for the alphabets. Now you can't shuffle BG with GB. If blue is for the background and G is for the alphabets, you can't write this as GB. That will be a different scenario, right? So in this scenario, the order will matter, and that is a permutation problem. Shall I move forward if there is no confusion? And please ask question if there is any confusion. Okay.
There is a hands up.
Yeah, I'm asking, please ask the question.
So, could you please repeat, like, what did you say?
I say that the easy way to identify the difference between the permutation and combination is to think that whether the reason of selecting is same or different. I give you example, and if you want to consider a case for the license plate, and in license plate you are selecting colors. First color is selected for the background of license plate, and second color is selected for the alphabets of the license plate. Now, for example, if I say that the first color is blue, which is selected for the background, and second color is green, which is selected for the alphabets, I cannot write this BG as GB, because in the first scenario, blue is for the background, but the other scenario, green is for the background. So that's why in this scenario, the order will matter. And the order will only matter when the reason of selection is not same. Got the point?
Okay.
Now
Yeah,
the next
thank
thing is about the combination. And for combination, consider a case that we have a school, and you want to choose two students. Okay, just see the case that we are selecting two students as a school representative. as a school representative out of all students in the school, for example. For example, there are total 10 students in school. So in how many ways we can do this? How many ways this can be done? Now in this scenario, you have total of 10 students, you are choosing 2 students for a school representation. Now the reason of selection is same. It doesn't matter whether you are selecting first student for representation, second. This could be, for example, this is first student A and second student B. You can also write this as first student B and second and A, because the reason of selection is same for both of these. But if I say that, for example, if I selecting 2 students for school presentation, and first one will be the president and second one will be the, for example, chairman. Now the order will matter. In our given scenario, you are just selecting 2 students for school representation out of 10. So it doesn't matter whether you are selecting first A or first B or first B, then A, right? But in other scenario, you are selecting 2 students for a school presentation and you are making first student as the president and second as a chairman. In that scenario, the order will matter because the reason of selection is not same in that scenario. Got the point?
Yes.
Isn't this an easy way to identify whether the problem is a permutation problem or combination problem? To be honest, I have found this be the easiest way to identify. Just remember, when the reason of selection is same, that will be a combination problem. When reason of selection is same or different, is same, that will be a combination problem because the order won't matter, and is different, that will be the permutation problem. Okay. Shall I move forward now? We will solve the examples of these in the next, when we just first proceed the advanced portion of this. Okay. This is understood by all, right? Okay. Now the next thing is about the reordering or arrangement. Reordering or arrangement, for example, in a linear order. By linear mean in a straight order for time being. Okay, for example, first consider a case, first scenario, in which we have all of these as distinct mean different. And if I say that, in how many ways I can arrange 2 person A, B in a linear arrangement? Ways of reordering or arranging 2 students, for example, 2 students, A and B, in adjacent position or in linear arrangement, in linear way arrangement, whatever you call this. So in how many ways we can do this? Either that will be A, then B, or that will be B, then A. So there are only 2 ways. Whenever we are ordering 2 students in a linear way, a linear arrangement, that could be A, first A, then B, or first B, then A, right? And if I just increase the total number of students to 3, so we have 3 students now, A, B, and C. And if I want to arrange those in a linear way, so in how many ways I can do that? that will be AB, AC, then BA, BC, and last will be CA and CB, right? So in short, there are total how many ways? 6 ways. But there must be some way that based on formula we can find this, that is just n factorial. And remember, this is for the distinct case. And that's mean n objects can be arranged on a straight line when those are distinct. Remember, those are distinct in n factorial ways. This is arrangement of n distinct objects in a straight line. This was first scenario, right? Now the second scenario is that if all objects are similar. At first we see the scenario in which all objects are distinct. If all are similar, that can only be arranged in one way. For example, all are A, right? All are similar. So this can only be done in one way, right? If all of these are distinct, use the formula n factorial, the way of arranging n objects in a straight line. And if all of these are similar, the way of arrangement will be only one. And remember, I'm right now just discussing the linear direction, linear way. I'm not discussing the circular. Circular is different. Okay, the next one is if we consider some sort of restrictions in the linear arrangement. But before getting into that, first let's see what is the fundamental counting principle, which we already discussed, but that is used. So I will just again give an idea. What is fundamental counting principle, which is FCUG, known as FCP. That anyone of you know about this? What is fundamental counting principle? It states that suppose we have a task. The thing is, we can divide a given task into several stages. And for example, the first stage can be done in A ways, A1 ways. The second can be done is A2 ways. The third can be done in A3 ways, and last can be done in, for example, N can be done in AN ways. So the total number of ways the task can be done, total number of ways tasks can be done are completed will be just the multiplication of all of those ways, A1 into A2 into A3 up to AN. This is a way of doing the first stage of the task, second stage of a task, third stage, fourth stage, up to the last stage, right? So you will just multiply all of these to get the total outcome. Why I told you this? Because if we just move to the restriction part, for example, if I say that we have 5 students. Yes. Ask the question. You want to ask something? You want more? Okay. 5 students, A, B, C, D, and E, and you have 5 chairs to arrange these. But the thing is, you have restricted that the third chair must be for example, E. So we have these 5 chairs. This is first chair, this is second chair, this is third chair, this is fourth chair, and this is fifth chair. The question is saying that the third chair must be for the E. So E must sit here. In how many ways E can sit in third? That is only one way. And now once E is already set down, we are left with 4 options. So using the fundamental counting principle, how many ways the students can sit on the first position, first chair? In 4 ways, because 1 is already occupied by E. And how many ways the student can sit in second position? That is 3 ways. In fourth position, that is 2 ways. And in fifth position, that is 1 way. So this will be 4 into 3 into 2. That is 24 ways. So whenever you see it, sir, try to think in terms of the fundamental counting principles. And restriction could be any way. This is a very simple case in which I restrict that E must sit in the center. There could be a scenario where I say that A and B must sit in adjacent positions. Or if I say that A must sit in the first position, E must sit in the last position. We will see several of such scenarios questions in the next class. Right now, I just want to give you an idea about the restriction, that how could restriction could be imposed in such scenarios. Okay, so if I move further, and till now everything is understood, right? Everyone is getting the point?
Yes.
Okay, so we discussed a distinct case. We discussed the identical. All of these are similar case. And now let's see the identical case in which some of the items are identical. For example, if I want to arrange A, B in an order, in a linear order, in how many ways I can do this? Let's see. The first way is A, B. The second is A, B, A. The third is A, B, A. And the last one is B, A. So there are total 4 ways. But if we see the distinct case, if we have 4 such difference, in that scenario, the total ways will be 4 factorial. So this is basically which is usually known as the Mississippi rule. And anyone of you know about the Mississippi rule? That when we are having some identical items, in how many ways we can arrange those in linear order?
So if identical items are, say, number of m are identical, then n factorial by n factorial.
Yes, exactly. So the thing is, in a set, with n items such that, for example, x items are identical, the total number of reordering or arrangement, whatever you call this, that will be n factorial divided by x factorial. But let's consider the more cases. For example, in a set with n items, total n items, there is one group of, by group I mean identical, x identical items, another group of y identical items, and another group of z identical items. So total number of reordering or arrangement will be equal to n factorial, the total factorial divided by first one x factorial into y factorial into z factorial, right? This is total number. This is the x repetition, the one group having x identical item. This is for the second one, this is for the third one. For example, if I give you the example of the Mississippi rule, that is, what is exact spelling of the Mississippi? I. Anyone of you know about what exact spelling? MISSI. There are total 11. So total number of arrangement in this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial. The total factorial divided by m came how many times? Only one time. 1 factorial. I came how many times? 1, 2, 3. 1, 2, 3, 4. This is for the m. This is for the I. And s 1, 2, 3, 4. Again 4 factorial for s. And for p, this is 2 factorial. Right? So this is just to give an idea that this is total factorial divided by m came one time. Doesn't matter. You can remove this. Then I came 4 times, 4 factorial. S came 4 times, 4 factorial, and P came 2 times, 2 factorial. So this will be 11 factorial divided by 4 factorial, 4 factorial into 2 factorial. This is total way of arranging Mississippi in a linear arrangement. So everything is understood till now. Now we will see the 4 cases. First of all, just to give an idea of with and without replacement. With or without replacement. To give an idea about without replacement, that means, for example, from a box, I want to pick 2 balls and I want to pick both of these in a different time. For example, first I pick 1 ball and in box I have 10 balls. So the way of picking the first ball is 10. But now I haven't put the ball back in the box. So in short, there are 9 balls remaining in the box. I just pick the second ball. So now I have nine ways of picking that ball, right? So this is about the without replacement. In this scenario, if an element selected once is not available for the subsequent selections, this is sampling without replacement, right? And the next one is with replacement. And the first scenario I told, if I pick the first ball of 10 ways, I just again put the ball back in the box. And now again, the way of choosing is 10, right? So that is with replacement. So that will be if an element selected once is again available for the subsequent selections, right? In the without replacement, one thing you pick is not available for the subsequent sampling or subsequent picking, and with replacement, that thing is available for the subsequent picking or for subsequent sampling. So now, and for example, in this scenario, let's start with an example. If I say that in a school, there are X students. There are X students, and we want to choose one student for president. We want to choose one student for the president and other student for the chairman. Other student for the chairman. In how many ways this can be done? Okay, so let's think, first of all, see, we have total X students and we want to choose two students, one for the president and one for the chairman. This is a permutation problem because the reason of selection is not same. The first selection is for the chairman and the second selection is for, the first is for the president and second one is for the chairman, right? So in this, the order will matter. That's why this is a permutation problem, first thing. And the next thing is, this is without replacement. Why this is without replacement? Because it is nowhere mentioned in the question then that same person could be selected for the president and for the chairman, right? So that's mean one must be selected for the president. Now out of the remaining, one should be selected for the chairman, right? So this is a without replacement case, and this is a permutation problem. Now let's see. The next thing is, if I see the president case, in how many ways I can select a president? That is total X ways, because I have total X students. And now in how many ways I can select the chairman? That could be in X minus 1 way, because the one person is already selected for the president and that person cannot contest for the chairman, and that person is out. And now I have X minus 1 ways of selecting a chairman. So total number of ways, so total way of selecting president and a chairman will be X into X minus 1 based on the fundamental counting principle. I just multiply those. And I can, if I want to come up with some sort of formula, I want to, if I do this way, X minus 2, X minus 3 up to 1 divided by X minus 2, X minus 3 up to 1, will this make any difference? No, because this will again cancel out. I want to make a formula, that's why I'm just doing some sort of iteration in this. So how can I write this? I can write this s factorial divided by x minus 2 factorial. Isn't this formula a bit familiar? So what exactly this formula? This is a permutation formula. That is exactly NPR. And we are just arranging R items out of N, and here R is equal to 2 and N is equal to X, right? So the takeaway is, whenever you have a permutation problem, and that is without replacement, then you can use this formula. That is NPR, which is equal to, let's call this X, in this scenario, XP2, which is equal to X factorial divided by X minus 2 factorial. So is this understood till now? This is first scenario, which is incorporating the order. That's a permutation problem. and this is without replacement. That's first scenario. Now let's see the other scenario. The other scenario is, again, I consider X students, and for example, I want to select 2 students from the school for school presentation and want to select 2 students for the school presentation. Now, whether this is a permutation problem or combination problem, this is a combination problem because the reason of selection for 2 students is same. Both are selected for the school presentation. This is combination problem. The next thing is this without replacement or with replacement? Yes, this is without replacement. Okay, so to build an idea about this scenario, let's consider a case. For example, we have what we discussed earlier. We have 3 students, A, X, Y, Z, and we want to make a committee of student presentation of 2 students out of this. So we did XY, XZ, YX, YZ, and ZY over ZX. In total, there are 6 ways if this is a permutation problem, but this is not a permutation, this is a combination problem. So I have to divide this with total arrangement so that I will get the combination thing. So that will be 6 factorial. That will be 6 divided by 2 factorial. 2 factorial is for the arrangement of 2 items. So this will be 3 ways. Likewise, if I see the scenario, what we are doing in this scenario, we are said that we have total X ways and we want to select 2 students. And if I just use the formula which we derive in the first scenario, that is X factorial divided by X minus 2 factorial. This was for the permutation. But in order to make this a combination problem, what will I do? I will divide this thing by 2 factorial, which is the arrangement. This will become X factorial divided by 2 factorial into X minus 2 factorial, which is a combination formula, which is NCR. And in this scenario, that is XC2, which is X factorial divided by X minus 2 factorial into 2 factorial, right? So if you're provided with a combination problem and the order doesn't matter, in that scenario, you will use simple NCR formula with this. This is second scenario. In first scenario, permutation problem, order doesn't matter. Permutation problem, order matters and without replacement. This is a combination problem and also without replacement. And the third scenario is about the and a third scenario. For example, consider a class with a class with 5 students. A, B, C, D, and E. We want to select from the class a student for the post of president. We want to select 1 student for president post. And we want to select another student for example, chairman post. And there is one more thing. The question says that one person can get more than one position, such that same person can get more than one position. Right? Now, if you see, we have total of 5 students, and one student is selected for the president and one for the chairman. So order matters because the reason of selection is not same. So this is a permutation problem, first thing. The next thing is that one person could be selected twice. That's mean this is a with replacement case. So in such scenario, if you get that same, that one person can get more than one position, that's mean this is a replacement problem with replacement, right? So this scenario is permutation with replacement. So if you want to, we have what exactly is asked in the question, you want to select two students, one is for the president and one is for the chairman. So for the seat of chairman, how many ways, in how many ways we can select? That is 5 way, because we have A, B, C, D, and E. We have 5 ways. First, let's see for the, okay. And for the president, again, we have 5 ways, because same person can be chosen for the both chairman and the president. So in both, we have 5 ways and 5 ways. So overall ways will be 5 into 5, which is 5 square. So in general, the formula is n power r. That's mean that we have n student and we are selecting r student for, let me write. So for n students, we select students for r pores such that one person can hold more than one positions or one post, right? So if I want to summarize all of the cases which we have discussed earlier, so that will be, if I want to summarize all of these. So remember, this is a repeated sampling. We are selecting more than once. And if I consider order in this side and replacement in this side, this, for example, this way, this order matters and order doesn't matter. And if in this side I consider two things, one is this is with replacement and this is without replacement. So the formulas will be for this, that will be n power r. For this will be npr. This will be ncr. And for this, there is no such formula. This depends from question to question. We will see this in the next lecture. There is no formula for this when we have with replacement and order doesn't matter. But remember, there are three basic formulas, basic scenarios. One is with replacement and which order matter. You can use this formula. The other one is without replacement, order matter. That is this. And without replacement, order doesn't matter. You can use this formula. This is just a summary of what we discussed, the three cases which we discussed earlier. So everything is understood till now.
Yes, yes.
And there is one last thing for today's lecture. And that thing is, to be honest, highly tested. that remember when you are using a combination formula, NCR, that is exactly equal to NCN minus R. Remember one thing. For example, N is equal to 5 and R is equal to 2. This means 5C2 exactly equal to 5C to 5 minus 2, which is 5C3. And if you want to validate this using the formula 5 factorial over 5 minus 2 factorial into 2 factorial, this is 5 factorial over 3 factorial into 2 factorial. And if you want to say this, this is 5 factorial over 5 minus 3, 2 factorial into 3 factorial. So these are exactly same, right? So just remember this, NCR is equal to NCN minus R. This is one thing. The next thing is if you are selecting 0 objects out of n objects, that will be n combination 0 will be always 1. Just remember this, when you are choosing 0 objects out of n objects, the result will be only one way. And when you are choosing n objects out of n objects, that is n combination n is equal to one way. And you can, as I told you that NCR is equal to NCN minus R, you can see that NC0 is equal to NC n minus n, which is NC0. Just leave this thing. Okay. And one last thing is that when you are choosing one object out of n objects, that's mean NC1 is equal to n ways, right? So just an idea, just a result based observation. When you are choosing 0 object, the result is only one way. When we are choosing all of the object, again the result is only one way. And when you are choosing only one object, the result is n ways.